Okay, so welcome to part 2 of 1-3, which is called Not Enough Numbers. So what we're going to look at here, these are going to be the area codes to your phone number. So it's going to be 3 numbers, and if we read all of this, basically it says right here, before 1995, these were all of the area codes out of the form NYZ. That NYZ just represents the 3 numbers of that area code. So it has those restrictions listed there for us. And then it says in 1995, since all the possible area codes were assigned, they removed a restriction, and we need to figure out how many they have now. So 1985, before then, that's what's going to ask us to do first. So I'll kind of talk it through, then I want you to try this problem out. And then same thing with the N1995, that one's a little trickier, so I'll help you out with that one as well. But if we look at our first one that we have, if we read through, N is any digit from 2 to 9, so we can be able to figure out how many are there. And then we get split into 2 scenarios. Y could be 2 numbers. It could be either 0 or 1. If it is 0, then it could be any digit. Z can be any digit from 1 through 9. And then if Y is 1, it could be any digit from 2 to 9. So we need to set up our 2 scenarios here. So I have our 2 scenarios set up. Scenario 1 is when Y equals 0. Scenario 2 is when Y equals 1. So, like the problems before, I want you to pause and try this one on your own. So, if you look at each combination, multiply across, add them up, and you will get our total answer. So, pause right now and figure out how many combinations were before 1995. Okay, so if we read carefully, we'll see that N will be any number from 2 to 9. So, it's going to be a total of 8 numbers on each of these. Of course, our Y's are going to be 1 number in each of those scenarios. And then Z is where we got to read closely. So if it's 0, if we read, it's going to be 1 through 9, so that's 9 numbers. If it's 2 through 9, that is going to be 8 numbers. Multiply across, we get 72, 64. Add that together, bam, final answer of 136. So now let's go ahead and take a look at since 1995. So that's when they lifted the restrictions up. So we have a new set of restrictions for each of our numbers. Where it gets a little interesting is going to be these parts right here with these 2 bullet points. So Z and Y can't equal each other, and he gives us some examples of those. So we need to take those out. And then the other exemption is that they're saving these 2 for future use. So we need to figure out our total number of combinations, which we can figure out through here. And then we need to figure out our restrictions with this one and this one. Once we have those, we can subtract that out and get our final number. So I want you to try this one on your own. So pause and try that. And then as you do that, I will explain how to get our final answer on this one. All right, so like I said, first thing we need to do is get our total number of combinations. So 8 for N, 9 for Y, 10 for Z. Multiply that across, I'm going to get 270. So now I need to look at these restrictions. First one tells me when A and Z, so the last 2 digits equal each other. Those are used for special purposes. So I need to figure out how many times Y and Z can equal each other, or how many numbers they have in common where they can equal each other. So that's going to be 9 times. So 9 numbers for Y, 10 numbers for Z. Of course, this Y can't be 9, so that's why we have 9 numbers there. So if those equal each other, it doesn't matter what N is going to be. So N right here is going to be 8. So we're going to multiply those 2 numbers together. So 72 is going to be the restrictions for that first one. The second one's a little easier. It says they're reserving those 2. So we just need to figure out how many digits Z is going to be in each case. And that is going to be 10 for each of them because we have 10 right there. So it's going to be 20 together. Subtract those out and we're going to get 628 as our final answer there. Okay, our last set of problems come for this one right here, and I would say this one's a pretty important one as well, as you'll see a question like this on your quiz. If we read through, a lot's going on, but really what we need to take in from this is these last sentence right here. It says that New Jersey changed its system of 3 letters followed by 2 numerical digits and 1 number to a new system of 1 number, 1 digit, and 4 letters. So we're talking about license plates here. If we just look at the back of your own license plate, you'll see it's made up of letters and numbers. So in the paragraph, it talks about how some states are running into issues where they're running out of combinations, so they need to come up with new combinations so they can give these out so everyone has their own unique license plate. So New Jersey system, as we see right there, they changed from 3 letters, 2 numbers, and a letter to 1 letter, 1 number, and 4 letters. So if we look at number 12, it just asks how many were under its previous system. So as we go through, it was 3 letters. So I'm going to go and let me give some more room here. So we got 3 letters, 1, 2, 3, 2 digits, 1, 2, and then 1 letter. So we'll put a dash there. So if I think about how many letters are in the alphabet, that's 26. So 26, 26, and 26, and we can put 26 there as well. And then how many numerical digits that we can have, that would be 10, 0 to 9. So I'm simply just going to multiply all of those numbers together, and when I do that, I'm going to get a pretty large number of possibilities for that. So we can just type all of that into our calculator and get an answer. And when we do that, we get 45,697,600 combinations here. So under the old system, that's how many they had. Number 13 asks how many additional license plates will New Jersey have under this new system. So they switched it up to a new system of a letter, a number, and then 4 letters. So it's asking how many new ones that we have. So I want you to try this one at your own. So go ahead and pause, try and figure out what our new number is, and then how many more they have compared to that 45 million that they had before. Okay, so if we multiply our numbers across, we're going to get over 118 million, almost 119, under this new system. And if you think about it, what's crazy is we only switched a number to a letter, and that's how many more that we got. Over 73 million just from that. So that's going to wrap up this lesson. Like I said, this one's probably the longest of the lessons that we have in this section. So those we just got to be careful on, read through our problems, and we should be good to go.